Welcome to the fourth and final video in our LED dimming fundamental series. Our first topic today is how to use the Vantage LED test report. We talked about LED test reports in the first video of this series and where to find them. We did not, however, go into any substantial detail about these. So that's what we'd like to do now. We'll start with the question, why do you care? There are two things that you will get from the test report. First, how well does this LED lighting product perform against the Vantage dimmers it is supposed to be compatible with? Does it meet the requirements of the project? If there are multiple dimmer choices, does the lighting product perform better against one dimmer than against the others? Secondly, what are the parameter values to apply to the dimmer in order to achieve best performance? So we'll take a look at a representative test report. At the top we see the header data, which identifies the report, has a description and some salient characteristics, states dimming compatibility, and the date it was tested. The next section is a compatibility chart. Each column displays the performance of the LED product against a specific Vantage dimmer. We test against one native Vantage dimmer per dimming technology, which represents performance against the entire range of compatible native dimmers. In this particular sample, which is compatible with either forward phase or reverse phase dimmers, we show performance against the standard dimmer module, model SDM12-EM, representing the line of forward phase dimmers, including the scene point dimmer, standard DIN dimmer, and so on. The next column represents performance against the EDIM mod, representing all Vantage native reverse phase dimmers. For forward phase dimmable products, we also compare against the RFLC universal dimmer, model DRD4, because its characteristics are different from the native Vantage forward phase dimmers. We show a pass-fail assessment per dimmer. In this case, we pass the product against all three dimmers. But just because we give it a pass doesn't mean it will perform to your expectations. There are no standards. So you will need to examine the remaining data in the report to determine whether it meets your requirements. Next, you'll find the power profile parameter values that give best performance. We'll illustrate in a moment how to apply these parameters on your project. While we can vary minimum on, maximum on, and adjust factor for the native Vantage dimmers, these are not variable with the DRD4. With the DRD4, we simply have two modes, standard or fluorescent, as you will find in the documentation. The best mode for the product is recorded here. Please note that the DRD4 has a neutral. Vantage recommends that you never use the non-neutral version DRD2 nor non-neutral scene point dimmers for LED loads. Finally, we display the maximum and minimum intensities. Because we apply a maximum on or high-end trim to native Vantage dimmers, we may see a slight reduction in maximum intensity, never less than 95%. The DRD4 maximum will always be 100% because there's no high-end trim. The minimum intensity, once the parameters are set for best performance, is represented both as perceived, which is on the same scale as the maximum intensity, and as measured. This is because the measured intensity is usually what a manufacturer will publish. It is important to recognize that the relationship between the perceived intensity and the measured intensity is a square relationship. So a published 1% dimming floor is typically the measured intensity corresponding to a 10% perceived dimming floor. We hear from customers from time to time that an LED doesn't dim to their satisfaction or appear to dim to the published value, where in reality it did meet the published value, but because of a lack of knowledge of the squared relationship between the two, the expectation was a lower dimming floor. It is important to understand this concept. The issue intensifies as the numbers grow. A published 10% dimming floor would correspond to a 32% perceived floor, meaning nearly the entire lowest third of the intensity range is unattainable. The next portion of the report is the graph, which shows perceived intensity versus dimming program level throughout the entire dimming range, after having applied the best fit power profile parameters. Here we graph the ideal straight line, which is a linearity curve, the dark blue line, as reference to compare the actual linearity per dimmer. The red line represents the standard dimmer module, the green line the electronic dimmer module, and the light blue the DRD4. You can see in this particular report that both native Vantage dimmer curves follow the ideal very, very closely. Your eye would likely not be able to detect that these don't follow the ideal exactly. The DRD4's performance, while with a couple of exceptions, is also pretty good. The top end is subject to dead travel because of the lack of high-end trim. The next section to call your attention to is the waveform capture, where for both forward phase and reverse phase, we have taken a recording of a single cycle of the signal, recorded at 100% and at 50%, showing both the voltage in blue and the current in red. Finally, we have the observation section, where flicker, smoothness issues, minimum load issues, and the like are recorded. In this particular report, we point out that on a forward phase dimmer, there is a sharp current spike where the triac fires, and on the reverse phase dimmer, there is no corresponding spike, but a better behaved current waveform. With this particular product, performance against forward phase and reverse phase native Vantage dimmers appears to be a tie, but this current waveform is the tiebreaker. So, where there is the freedom to choose, I would recommend the EDIM mod. But it would be acceptable to use the product with an existing installed forward phase dimmer. Make sure to check out the guide to reading an LED test report on the Vantage Professional Support website, where you will find more information related to this topic. We'll now review the application of power profiles to lighting loads in a Vantage Infusion system. With the current project file open within Design Center software, we follow 4 steps. Step 1, within the Style Profile view, we create a new power profile. There are 3 types of power profiles. Default for forward or reverse phase dim loads, known simply as power profile. DC profile for 0 to 10 dim loads, and PWM power profiles for PWM dim loads. Once we select